डियर स्टूडेंट्स, कैसे हैं आप? तो बच्चों, आज हम सीक्वेंस एंड सीरीज की लास्ट एक्सरसाइज करने जा रहे हैं, एक्सरसाइज 9.4. दैट इज वेरी वेरी इंपॉर्टेंट एक्सरसाइज फॉर एग्जामिनेशन एज वेल एज कंपटीशन पॉइंट ऑफ व्यू. बिफोर डिस्कसिंग दैट एक्सरसाइज, we have to remember some formulas. The first formula is the sum of first and natural numbers. 1 plus 2 plus 3 plus 4 and so on up to n. That can be written in short sigma k, where k is equal to 1 to k is equal to n, or it can be written as simply sigma n, nth term sigma n. And its value is n into n plus 1 upon 2. It can also be derived from the formula of arithmetic progression because it is an AP. This formula is the value of Sn for this sequence. We have to remember that the value of 1 plus 2 plus 3 plus 4 and so on up to n is equal to n into n plus 1 upon 2. Similarly, the second formula is the sum of the squares of the first and natural numbers. That is equal to sigma k square. N square is then it convert it into another variable k square, where k is equal to 1 to k is equal to n, or it can be written as sigma n square, simply, in short. And its value is n into n plus 1 into 2n plus 1 upon 6. You must have remembered this formula in order to solve the applications of the exercise 9.4. The last formula is the sum of the cube of the first and natural numbers. 1 cube plus 2 cube plus 3 cube plus 4 cube and so on up to n cube. It can also be written in short sigma k cube, n cube, then it convert it into k cube, k is equal to 1 to k is equal to n, or it can be written in simply sigma n cube, and its value is n into n plus 1 upon 2, same as the above. What here difference is that it should be square, n into n plus 1 upon 2 whole square. These are very very important in this exercise. And at last, for such type of sequences in which we cannot adopt the formula of AP or GP, or these sequences are neither AP nor GP, then simply find the nth term of that sequence, and taking the sigma of the nth term, we get the value of Sn. Hence, formula becomes Sn is equal to sigma Tn or sigma Tk, k is equal to 1 to k is equal to n. So, these are the 4 important formulas which are applicable in the exercise 9.4 of the sequence and series. That's all. Now question number 1, exercise 9.4. Find the sum to n terms of the sequence 1 into 2 plus 2 into 3 plus 3 into 4 plus 4 into 5 and so on. So it is clear that this sequence is neither an AP nor a GP, because if we multiply these terms, it becomes 2, it becomes 6, and it becomes 12. 12 upon 6 is 2, but 6 upon 2 is 3. There is not common ratio. Hence, these terms are not in geometrical progression. In the similar manners, they are not in AP, because 12 minus 6 is 6, what 6 minus 2 is 4. There is not common difference between the successive terms. Hence, this sequence is neither an AP nor a GP. Then, what is the method to find the sum to n terms? Which formula is applicable? The formula applicable is, let us find the nth term of this sequence. In the first term, there are 2 numbers. In the second term, there are 2 numbers. In the third term, there are 2 numbers. In the fourth term, there are also 2 numbers. Therefore, in the nth terms, will be the product of the 2 numbers. And they can be calculated easily. So here, Tn, nth term, will be equal. First term start from 1, then 2, 3, 4. Therefore, nth term will contain the first number, that will be the n. 1, 2, 3, 4 and so on n. Into the second number of the nth term of the sequence will be 1 more than the previous. This is 2, then this is 3. 3, then 4. 4, then 5. This is n, then next will be n plus 1. We have calculated the nth term of this sequence by judgment method. Otherwise, you can adopt the formula of AP. In case of first number, we will find the nth term Tn will be equal to A plus n minus 1 into D. Similarly, second terms are also in AP. You can find the second term also by the method of AP, nth term of the AP. First term is 2 and common difference is 1. You can find this. And we can also find by judgment very easily. First term is 1 into 2, second term is 2 into 3, third term is 3 into 4, nth term will be n into n plus 1. Therefore, it becomes n square plus 1. 1 into n, that is n. This is nth term. Hence, Sn will be is equal to sigma Tn. We have not converted Tn into Tk. We are applying the formula, simple formula, sigma Tn. That is equal to sigma n square plus n. And it becomes sigma n square plus sigma n. Now putting the value of sigma n square, the value of sigma n square is that of the sigma k square, where k is equal to 1 to n. And here value of sigma k is equal to 1 to n. The sum of the first n natural numbers and the sum of the square of the first n natural numbers. By putting these values, we can find the value of Sn. Sn is equal to sigma n square plus sigma n. Putting in the value of sigma n square or sigma k square, where k is equal to 1 to n, we get n into n plus 1 into 2n plus 1 upon 6 plus value of sigma k or sigma n, sum of the first natural numbers, first n natural numbers, that is n into n plus 1 upon 2. Taking n into n plus 1 upon 2 common from these, we get n into n plus 1 upon 2 common, we get 2n plus 1 upon 3. 2n plus 1 upon 3, n into n plus 1 upon 2 is common. Plus 1, 1 upon 1. Taking LCM, we get the next factor that is n into n plus 1 upon 2 into 2n plus 1 plus 3 upon 3, that is equal to n into n plus 1 upon 2 into 2n plus 4 upon 3. Now it becomes n into n plus 1 upon 2 into 2n plus 4 upon 3. Dividing 2n plus 4 by 2, we get n plus 2. n into n plus 1 into n plus 1 upon 3, because 2 is cancelled by taking 2 common from 2n plus 4. And this is the answer of this questions. Hence, this is the method to find the sum to n terms of a sequence, which is neither NAP nor a GP. But in such type of sequences, we can find the value of nth term very easily. Then taking simply the sigma of nth terms, we can find Sn for such type of sequences. That's all. Now question number 5, exercise 9.4. Evaluate 5 square plus 6 square plus 7 square plus and so on up to 20 squares. 5 square plus 6 square plus 7 square plus and so on to 20 squares can be written as, by adding the some terms, 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square plus 7 square and so on up to 20 square. We have added these 4 terms. Hence, also subtracting these 4 terms, minus 1 square plus 2 square plus 3 square plus 4 square. Now it becomes 1 square plus 2 square plus 3 square plus 4 square and so on up to 20 square. We can apply the formula of sigma n square, where role of n is played by 20, and in this case role of n is played by 4, because sigma n square is equal to n into n plus 1 into 2n plus 1 upon 6. Therefore, putting n is equal to 20, we get 20 into 20 plus 1 into 2 into 20 plus 1 upon 6. And here n is equal to 4 minus 4 into 4 plus 1, 2 into 4 plus 1 upon 6. Now after calculation, it becomes 20 into 21 into 22 is 40 plus 1 41 upon 6 minus 4 into 5 into 4 to the 8 plus 1 9 upon 6. 20 upon 6 common, we get 21 multiplied by 41 minus 9. Now after multiplications, 21 by 41 we get 860 minus 9. After this, it becomes 20 upon 6 multiplied by 552. 861 minus 9 is 552. After cutting, 3 to the 6 and 10 to the 20. 3 to the 6, 3 8 the 24 and 3 4 the 12, 284. Multiplications of 10 and 284, we get the answer of these questions, that is 2840. So this is the procedure to tackle such types of problems which are neither AP nor GPs. We can find the sum by the formulas of this exercise. That's all.